Good afternoon, everyone. Good afternoon. Good afternoon. Hope all of you are doing great, having the good time at home. People, if I'm audible and visible to everyone, let me know in the chat box with the thumbs up. If I'm audible and visible to everyone, let me know in the chat box. Let me know in the chat box fast. Let me know in the chat box. Let me know in the chat box if I'm audible and visible to everyone with the thumbs ups. Yes, Yashwant, I had my lunch. Yes, absolutely. Yes. That's great. That's great. Okay. So as you all must be knowing, in the last session of equilibrium, we started the KP-KC calculations. And in the today's session, we are going to continue the same topic in which I'll be teaching you how to calculate the KP and KC for different reactions, right? Okay. So before starting the session, guys, let me introduce myself. As you all must be knowing, my name is Wassim Sir and I'm your chemistry master teacher right here, okay? And before starting, as I always say, do like, share and subscribe the channel so that everyone will get benefited out of these lectures, right? That's great. Okay, talking about the Vedantu NEET Pro Subscription, let me tell you what all benefits you guys are going to get if you will get enrolled in this Pro Subscription. The first benefit, you guys are going to get 5,000 plus hours of live online teaching, right? Regular tests and assignments will be provided to you, which contains more than 10,000 questions. We have got 20 plus teachers with 5 plus years of experience who will be constantly helping you out personally and training you personally for your NEET 2021 or 2022. Okay, and at the same time, let me tell you, you have got complete liberty to learn either in English or in Hindi. It's completely your wish to select the language. You can select the language, get trained personally for your NEET 2021 and 2022. And at the end, in this Pro Subscription, we are covering everything, which also includes your micro as well as crash courses. Okay. Now, people, for the ones who are going to appear in the NEET in 2021, we have come up with 3 different plans for you. And for every plan, you are having 20% off, okay? The 1 month plan, for the people who are going to appear in the NEET in 2021, the 1 month plan after 20% off, you are getting it just for 6K. 3 month plan after the 20% off, you are getting it for 16.8, and 6 month plan after the 20% off, you are getting it for 31.2K, right? All these plans are valid for the ones who are going to appear in the NEET in 2021. Similarly, for the people who are going to appear in the NEET in 2022, again, we have come up with 4 different plans. You can have a look. On every plan, we have got 20% off right here. The 1 month plan after the 20% off, you guys are getting it just for 4K. 3 month plan after the 20% off, you are getting it for 10.8K, and 6 month plan after the 20% off, you are getting it for 19.2K, and the last one, 12 month plan after the 20% off, you are getting it just for 33.6K. And all these plans are valid for the ones who are going to appear in the NEET in 2022. Similarly, we have got different plans for the droppers as well. 3 different plans for the droppers, 1 month, 3 months, 6 months, and on every plan you have got 20% off, and after the 20% off, you are getting the 1 month plan just for 7.2K, 3 month plan after the 20% off, it is for 20.4, and 6 month plan is just for 40.8K after the 20% off. And these plans are valid for the droppers. So hurry up, guys, get enrolled in the long-term batches, get trained for the NEET 2021 and 2022 personally by the master teachers of Vedantu, right? Now the point is how to avail this discount, how to avail this 20% off. Let me tell you, there is one link in your description box. Just click on the link, use the coupon code as WSPRO. After using this coupon code of WSPRO, you guys are going to get the 20% off in whatever plan you are selecting among all, okay? So, should we start with the session, guys? Are you guys super excited for the today's session as well? Let me know in the chat box if you guys are damn excited for the today's session as well. Let me know in the chat box. Let me know in the chat box. Hi Priya, I'm doing great. I'm doing great. Good afternoon, Rahul. Good afternoon. Hi Nikhil. That's great, Mohsen. That's great. That's great. That's great. Wonderful, guys. Wonderful. So actually, you guys are super excited. Vinay, I'm doing wonderful. How are you doing? Okay, that's great. So people, let's get started with the session in which we are going to talk about the Kp and Kc calculations for different type of reactions. If you guys remember, in the last session, I showed you how to calculate the Kp and Kc for the reactions whose delta Ng value is going to be 0. And in the today's session, we are going to talk about the reactions for which delta Ng value will be greater than 0 and less than 0. How to deal with those reactions, okay? That's what we have to talk about in the today's session. All right? So let's get started over here. Just give me a second. Let me select the marker over here first. Okay. See guys. First of all, I'm going to talk about those reactions for which delta Ng is going to be greater than 0. How do we calculate Kc and Kp for the ones? How do we calculate Kc and Kp for the reactions for which delta Ng will be greater than 0? That's what we have to check, okay? First of all, just give me a second, guys. Just give me a second. There is something wrong over here, yeah? Do you guys think there is something wrong over here? Definitely there is something wrong. Let me erase this reaction over here. Let me erase this reaction. Let me write my reaction, okay? See, for example, I'm having a homogeneous gaseous reaction like this. Let's say the reaction is A gas is getting converted to B gas plus C gas, okay? This is one homogeneous reaction, homogeneous gaseous phase reaction, which is given to me. Got it? Now, people, if I want you guys to calculate delta Ng for this reaction, can you do that? Definitely, I have shown you how to calculate delta Ng, right? And we know delta Ng is always equal to number of moles of gaseous products minus number of moles of gaseous reactants. Very simple, okay? And all the species, all the reactants and products over here, all the ones are in gaseous phase. Right? So how many moles? How many moles? I'm assuming the reaction to be balanced. How many moles of gaseous products do we have? 1 plus 1, that is 2. Minus how many moles of gaseous reactants do we have? We have got 1 mole. So 2 minus 1 is going to come as 1. So can I say delta when Ng value over here for this reaction is coming out to be greater than 0? Now we have to talk about those reactions only right now whose delta Ng is going to be greater than 0. Okay, very, very simple. Now guys, have a look. For example, this reaction, it is taking place in some container whose volume is, for example, V. The reaction is taking place in a container whose volume is, for example, V liters, for example, okay? Right? So I can say volume of the system right here is V liters, correct? Now people, first of all, I'm going to show you how to calculate Kc value over here for the reaction whose delta Ng is going to be greater than 0. Yes, Kiran, definitely. I know physics, wala, absolutely, yeah. Okay, now people have a look. At time t is equal to 0, if I'll write a statement at time t is equal to 0, what does it mean? That means the reaction has not started yet. That means the products have not got formed yet, okay? So I'm saying at time t is equal to 0, let's say I have got A moles of this reactant. Let's say at time t is equal to 0, I'll be having A moles of this reactant. So do I have any sort of moles of B and C at time t is equal to 0? No way, right? Very, very simple, because the reaction has not started yet. Now people, let's say at equilibrium, out of A moles of this reactant, out of A moles, X moles have got converted into products. So how many moles of this reactant will be left at equilibrium? I would say A minus X moles will be left at equilibrium. Very, very simple. Correct? Now I need to check how many moles of B and C got formed at equilibrium. And how do I do that? In the last session, we have talked about that as well. Very simple. I'll be using the stoichiometry. See guys, 1 mole of A, it gives 1 mole of B. So X moles of A should give me X moles of B. Very simple. At the same time, 1 mole of A gives 1 mole of C. So I would say X moles of A should give me X moles of C. So can I simply say I got the moles of reactants and products which are present at equilibrium in the container? Very, very simple. Correct? Now guys, if I'll divide these moles by the volume of the system, what do I get? I told you in the last session. How do we define concentration? Simply, concentration is defined as number of moles divided by volume. Very, very simple. This A minus X, these were the moles of the reactant, left at equilibrium. I divided these moles by the volume of the system. Now this whole term is going to give me the concentration of reactant at equilibrium. This term is going to give me the concentration of this B at equilibrium, and this term is going to give me the concentration of C at equilibrium. Very, very simple. Yeah, very simple. Now people, if I want to write the expression for Kc over here for the reaction, how do I write that? How do I write that? Already all of you must be knowing. Kc expression will be equal to, I'll be starting with this product right here, okay? And for the gases, if you remember, for the gases, I told you we define both the terms, concentration as well as pressure. Over here, I'm writing Kc, so I have to use the term concentration. Very, very simple, very, very simple. Now people, can I write Kc is going to be equal to concentration of B to the power stoichiometry coefficient, that is 1, multiplied by concentration of C to the power stoichiometry coefficient 1 divided by concentration of A to the power 1. Very, very simple. And if I'll ask you, what is this B over here? Is this the initial concentration of B, or is this the concentration of B at equilibrium? What is going to be your answer? This B, this over here, this term is the concentration of B at equilibrium. Over here, this is the concentration of C at equilibrium. This is the concentration of A at equilibrium. Very, very, very simple. Got it? Now people, I have all the values. I just have to put all the values into this equation. I'll get the value of Kc for the reaction. Very, very simple. So Kc is going to be equal to concentration of B, that is x by V. Concentration of C, that is again x by V. So isn't it going to be x square divided by V square? Whole divided by concentration of A at equilibrium. It's going to be equal to A minus X divided by V. It's going to be equal to A minus X divided by V. Can I say this V square and this V got cancelled? So I got the value of Kc for the reaction as x square divided by V multiplied by A minus X. This is my expression for Kc for the given reaction which I have over here. Is it clear to everyone, guys? Let me know fast in the chat box. Is it clear to everyone? Let me know in the chat box. Let me know in the chat box. Is it clear to everyone? Yeah? That's wonderful. That's great. That's great. Okay, this was the Kc expression for the reaction. Can we simply write the Kp expression for the reaction? We can do that. We can write the Kp expression as well. And how do we write the Kp expression for this reaction? For that, have a look, guys. I'm going to erase it. I'm going to erase all this, okay? I'm going to erase all this, and let me show you how to write the Kp expression for the same reaction which I have over here on the screen, okay? See, guys, have a look. Initially, I have A moles of this reactant, 0 moles of this, 0 moles of this. Now at equilibrium, I'm assuming out of A moles of reactant, X moles have got converted into products. So how many moles of reactant are going to be left at equilibrium? A minus X. How many moles of this product are going to get formed? X. How many moles of this product are going to get formed? X, right? Just now I told you how to do it, correct? Now people, have a look. These are the moles of A left at equilibrium. These are the moles of B formed at equilibrium. These are the moles of B formed at equilibrium. Now if I'll ask you, how many total moles will be there in the container at equilibrium? If I'll ask you, how many total moles will be there present in the container at equilibrium? You will say A minus X plus X plus X. X and X will get cancelled out. So total moles at equilibrium are going to be A plus X. Very, very simple. Okay. Now people, if I'm dividing, let me show you what am I going to do. See, guys, if I'll divide these moles of reactant by the total moles present in the container, that is A plus X, right? I'm dividing this also by the total moles, which is A plus X. I'm dividing this also by the total moles, which is A plus X. Can I say I got the mole fraction of each reactant and product at equilibrium, right? I got the mole fraction of each reactant and product at equilibrium. Very, very simple. And in the last session, if you remember, I told you how to convert mole fraction into the total pressure. Let's say at equilibrium, total pressure of the mixture of the gases at equilibrium, total pressure in the container is, for example, equal to P. P is the total pressure in the container at equilibrium. will that total pressure be only due to moles of A left, or moles of B formed, or moles of C formed? No way. The total pressure of the container at equilibrium will be due to moles of A as well as moles of B as well as moles of C, right? Very simple. Very simple. Now people, if I'll multiply this mole fraction of reactant by the total pressure, what am I going to get? This term is going to give me the partial pressure of A at equilibrium. Very simple. If I'll multiply this term by the total pressure of in the container at equilibrium, this whole term is going to give me the partial pressure of B. And similarly, if I'm going to multiply this term by the total pressure, this whole term is going to give me the partial pressure of C as well. Very, very, very simple. Got it? Very, very, very simple. Right. I got the partial pressure of all the reactants and products at equilibrium. I can write the Kp expression now. Very simple. Kp expression is going to be equal. Right now I'm talking about Kp, so I have to take the partial pressures of products and reactants over here. Then only I can write the expression for Kp, as you all must be knowing, correct? Very simple, guys. Kp is going to be equal partial pressure of B to the power stoichiometric coefficient of B, that is 1, multiplied by partial pressure of C to the power stoichiometric coefficient of C, that is 1, divided by partial pressure of A to the power stoichiometric coefficient of A, that is 1. Do I have all the values? Do I have all the values over here? Do I have all the values? What is this B over here? What is this PB over here? Is this the pressure of B at time t is equal to 0? What do you think? Is this the pressure of B at time t is equal to 0? Let me know in the chat box fast. What is this PB? Is it the pressure of B at time t is equal to 0? No way, no way. This is the pressure of B. This is the partial pressure of B at equilibrium. This is the partial pressure of C at equilibrium. This is the partial pressure of A at equilibrium. This term is called as partial pressure of A at equilibrium. This is called as partial pressure of B at equilibrium. And this whole term is called as partial pressure of C at equilibrium. Do I have all the values? I can put all these values into this expression. I'll get the value of Kp. Isn't it clear? Isn't it clear? Isn't it simple? Isn't it simple, guys? Let me know in the chat box fast. Isn't it simple? Let me know in the chat box fast. Let me know in the chat box fast. Isn't it very, very, very simple? Exactly. This is how you'll be approaching the equations for which delta Ng is going to be greater than 0, right? The procedure which I have shown you over here, this procedure is valid for the reactions for which delta Ng will be greater than 0. Very, very simple. Got it? Okay. If this is clear to you, I can show you one more thing. This is the reaction for which delta Ng is less than 0, correct? This is the reaction for which delta Ng is less than 0. How do we approach to these sort of questions? How do we approach to these sort of reactions for which delta Ng will be less than 0? First thing, how come delta Ng is less than 0 for it? Delta Ng, if I'll write, delta Ng for the reaction is equal number of moles of gaseous products, that is 2, minus number of moles of gaseous reactants, which is 1 plus 3, which is 4. So 2 minus 4 will come out to be minus 2 over here. So this minus 2, delta Ng is coming out to be negative. So I would say delta Ng over here is less than 0. And how do we approach these sort of questions in which delta Ng is going to be less than 0? Have a look, guys. Have a look. Understand properly. First thing, I'm going to calculate the expression for Kc. I'm going to show you how to write the expression for Kc for this sort of a reaction, okay? And this is a general reaction which I've taken. And it's balanced at the same time, and it's homogeneous gaseous phase reaction at the same time, right? Now, let's assume at time t is equal to 0. Let's assume at time t is equal to 0 when the reaction has not started, when the product has not got formed. Let's say at time t is equal to 0, I have A moles of N2, I have A moles of H2. Okay, let's assume I have A moles of N2, I have A moles of H2. Will I be having any moles of NH3 at time t is equal to 0? I'm not going to have any moles of NH3 at time t is equal to 0, right? Very, very simple. Now guys, what am I going to do? I'm assuming at equilibrium. For example, out of A moles of N2, for example, X moles of N2 have reacted. If X moles of N2 have reacted, how many moles of N2 I'll be left with at equilibrium? Won't I be having A minus X moles? Very simple. Say, I took A moles of N2, B moles of H2 at time t is equal to 0. And now I'm assuming out of A moles of N2, let's assume X moles of N2 have reacted. So I'll be left with A minus X moles of N2 at equilibrium, correct? Now, how many moles of H2 will be left at equilibrium? If I'll ask you, how many moles of H2 will be left at equilibrium? What do you guys think? Very simple. See, use the stoichiometry. 1 mole of N2 reacts with 3 moles of H2. 1 mole of N2 reacts with 3 moles of H2. So, X moles of N2 should react with 3X moles of H2. Very simple. 1 mole of N2 reacts with 3 moles. So, X moles should react with 3X. How many moles I had? A. Out of A, how many are reacting? 3X are reacting. So I'll be left with A minus 3X moles of H2 at equilibrium. Very simple, right? Now, if I'll ask you, how many moles of NH3 would have got formed at equilibrium? Very, very simple again. See guys, 1 mole gives 2 moles. 1 mole gives 2 moles. So X moles should give me 2X moles of NH3 at equilibrium. So moles of NH3 at equilibrium are going to be 2X. Moles of N2 left at equilibrium are going to be A minus X. Moles of H2 left at equilibrium are going to be A minus 3X. Very simple. The reaction in which, the container in which this reaction is taking place, for that container, volume is, for example, V liters. Volume is V liters, right? Now the point is, if I'll divide this term by V, if I'll divide this term by V, if I'll divide this term by V, what do I get? What do I get? Very simple. Now this term is going to give me the concentration of N2 left at equilibrium. This term is going to give me the concentration of H2 left at equilibrium. This term is going to give me the concentration of NH3 formed at equilibrium. Very, very simple. Yeah? Yeah, guys? Very simple. Now I can write the Kc expression. And now I can write the Kc expression, which is going to be concentration of NH3 to the power 2, which is stoichiometric coefficient of NH3, divided by concentration of N2 to the power stoichiometric coefficient, that is 1, multiplied by concentration of H2 to the power stoichiometric coefficient, that is 3. Right? Do I have the concentration of NH3 at equilibrium? Definitely. This term is the concentration of NH3 at equilibrium. Correct? Do I have the concentration of N2 at equilibrium? Definitely. This term is basically the concentration of N2 at equilibrium. And what about this term? Isn't it the concentration of H2 at equilibrium? Definitely. That means I have got all the values. I can put these values into this equation. I'll be getting the value of Kc over here. I'll be getting the value of Kc over here. Very, very simple. Very, very simple. Okay. This is the procedure which is going to, which I'll be following in order to calculate Kc for these sort of reactions which have got delta Ng less than 0. Got it? Now, what about Kp? What about Kp? How do I calculate Kp? Again, the same procedure. Again, the same procedure which you already know. Again, the same procedure which you already know. I'm going to erase it. Have a look. Let's try to calculate Kp for the same reaction. Let's try to calculate Kp for the same reaction. See, guys. Again, I'm starting from the same thing. At time t is equal to 0, I have got A moles of N2. I have got, for example, A moles of H2. I have got 0 moles of NH3. Very simple. Now, for example, out of A moles of N2 at equilibrium, out of A moles of N2, let's assume X moles have reacted. X moles have reacted. So, how many moles of N2 will be left? I'll be left with A minus X moles of N2. Okay. Now, 1 mole reacts with 3 moles. 1 mole of N2 reacts with 3 moles of H2. X moles should react with 3X. So how many I'll be left with? I'll be left with A minus 3X moles of H2. How many moles of NH3 would have got formed? 1 mole gives 2 moles. So X moles should give 2X moles. Did I get the moles of each reactant and product at equilibrium? Definitely. Right? Definitely. I got the moles of each reactant and product at equilibrium. And I'm assuming the total pressure of the mixture at equilibrium is P. Let's say the total pressure of the mixture at equilibrium is P. Can I calculate the total number of moles present in the mixture at equilibrium? Definitely I can do that. Total number of moles present in the mixture at equilibrium is going to be this, right? So it's going to be simply A minus X plus A minus 3X plus 2X. Right? Very, very simple. Very, very simple. So it's going to be equal to what? This is A plus A, that is 2A. This is minus X, minus 3X, minus 4X plus 2X. This is going to be minus 2X. So I got the total moles present in the container at equilibrium as 2 into 2 into A minus X. Very, very simple. Now people, if I'll divide these moles by the total moles present in the mixture. Wait, there is something wrong, isn't? This is A minus X, this is A minus 3X, this is 2X, right? So this is going to be minus 4x plus 2x is going to be minus 2x. So this is 2a minus 2x. Okay, fine. Let's proceed. Okay, now I'm going to divide this by 2 into a minus x, and this also I'm going to divide with the total moles, which is 2 into a minus x. Very, very simple. So people, what did I get over here? Is this term giving me mole fraction of N2 at equilibrium? Is this term giving me mole fraction of H2 at equilibrium? Isn't this term giving me mole fraction of NH3 at equilibrium? Right? Right? Right, guys? I got the mole fraction of each reactant and product at equilibrium. If I'll multiply them by the total pressure of the gaseous mixture at equilibrium, if I'll multiply everyone by the total pressure of the gaseous mixture at equilibrium, what am I going to get? What am I going to get? Can I say this whole term is going to give me the partial pressure of N2 at equilibrium? Can I say this whole term is going to give me the partial pressure of H2 at equilibrium? Can I say this whole term is going to give me the partial pressure of NH3 at equilibrium? Right? Right, guys? Yes, Christina, you can do that. You can do that. Why not? Why not? Why not? Now, guys, I got the partial pressures of each reactants and products at equilibrium. Can I simply use the expression for Kp? We know how to write Kp expression. All of you must be knowing. So Kp is going to be equal. I'll be starting from the product. Product is NH3. So I'm writing partial pressure of NH3 to the power what? To the power square. To the power 2, because stoichiometry coefficient of NH3 is 2. Now talking about reactant, so it's going to be partial pressure of N2 raised power stoichiometry coefficient 1 multiplied by partial pressure of H2 raised power stoichiometry coefficient 3, right? This is the partial pressure of NH3 at equilibrium. This is the partial pressure of N2 at equilibrium. This is the partial pressure of H2 at equilibrium. Do I have all the values? Definitely have all the values, right? I have all the values. I can put these values into this equation. Can't I get, am I going to get the value of Kp for the reaction? What do you guys think? What do you guys think? What do you guys think? Tell me fast, tell me fast. Tell me fast. Is it clear? What do you guys think? Yeah? Exactly. This is how we calculate Kp for the reaction whose delta Ng is going to be less than 0, and the reaction is like this. Okay. Now people, let's try to apply all these concepts right here. Let's try to, what are you saying? Moles of H2, 3A. I have already taken moles of H2 as A only. Okay. Now people have a look. Let's try to apply all this, okay? Let's try to apply all these concepts in the questions. The first question, which you can see, that's on your screen. A very simple question it is, but it might be, the calculation part might be lengthy, right? See, guys, what the question is all about. See, 1 mole of N2 and 3 moles of H2 are placed in 1 liter vessel. Find the concentration of NH3 at equilibrium. If the equilibrium pressure is 1 atm, the equilibrium constant Kc at 400 Kelvin is 4 by 27. What are we supposed to calculate? We are supposed to calculate the concentration of NH3 at equilibrium, right? Now, see guys, what am I going to do? The reaction will be when N2 reacts with H2, what do I get? When N2 gas reacts with the H2 gas, what do I get? I get NH3. I get NH3 gas. This is something which I get. Okay. For example, let's try to balance the reaction first. This should be 3 times. This should be 2 times. Now the reaction is balanced. Right? Now what is given to me? At 400 Kelvin, I'm given with the Kc value for the reaction. At 400 Kelvin. How much is that? That is 4 divided by 27. This is something which is given to me. And at the same time, what else is given? See guys, at time t is equal to 0, initially I'm given with 1 mole of N2 and I'm given with 3 moles of H2 initially when the reaction has not started. Right? And the container in which the reaction is taking place, the volume of that container is 1 liter. Can I say number of moles of NH3 at time t is equal to 0 is going to be 0? Right? Can I do that? Can I do that? Can I do that? Very simple. Now guys, have a look. Now see how to approach this sort of a question. Let's assume at equilibrium, out of 1 mole of N2, let's assume X moles have reacted. If out of 1 mole of N2, X moles have reacted, so how many moles of N2 will be left at equilibrium? I would say 1 minus X moles. Right? Now guys, see, 1 mole of N2 reacts with 3 moles. So X moles should react with 3X moles. And how many moles of H2 I had? I had 3 moles. Out of 3 moles, how many moles of H2 are reacting? I would say 3 minus 3X moles of H2 are reacting. Very simple, right? At the same time, 1 mole gives 2 moles. So X moles should give me 2X moles, right? Very, very simple. I got the moles of all the reactants and products at equilibrium. Correct? Now people, I'm given with Kc value. Understand properly. What am I supposed to calculate? Find the concentration of NH3 at equilibrium. Say, these are the moles of reactants and products at equilibrium. If I'll divide these moles by the volume 1 liter, can I say same is going to be the concentration as well? Hi Sudan, how are you? Say, these are the moles of reactants and products at equilibrium. If I'm going to divide these terms by the volume, do I get the concentration of each reactant and product as well, which is going to be same, divide by 1. So I got the concentration. Right? Right guys? Now, this is the concentration of N2 at equilibrium, this is the concentration of H2 at equilibrium, this is the concentration of NH3 at equilibrium. Now what am I going to do? I'm supposed to calculate the concentration of NH3 at equilibrium. And we know the concentration of NH3 at equilibrium is 2x. So basically I'm supposed to calculate the value of 2x. Right? Because I'm supposed to calculate the concentration of NH3 at equilibrium. So what am I going to do? Concentration of NH3 at equilibrium is 2x. So I'm supposed to calculate the value of 2x, and whatever will be the value of 2x, that is going to give me the concentration of NH3 at equilibrium. Correct? Now guys, understand one more thing. I'll simply write the Kc expression over here. What will be the Kc expression for the reaction? It's going to be concentration of NH3 at equilibrium raised power 2 divided by concentration of N2 at equilibrium raised power 1 multiplied by concentration of H2 at equilibrium raised power 3. Correct? And this value is given to me, Kc value is given to me as how much? It's given to me as 4 divided by 27. So what am I going to get? Concentration of NH3 at equilibrium is 2x. So this is going to be 2x ka square whole divided by concentration of N2 at equilibrium. That's equal to 1 minus x. Multiplied by concentration of H2 at equilibrium ka cube, right? This is 3 minus 3x. This is 3 minus 3x ka what? 3 minus 3x ka cube. Right? And this value is given to me as 4 by 27. Now the point is how to solve this equation. Right? See guys, how to solve this equation. For that, I have to erase this part. I'm sure all of you must have written till here. Right? Now I'm going to show you how to solve this equation. The equation is like this. The equation is 2x ka square divided by, see, this is 1 minus x, okay? Now this is 3 minus 3x ka cube. Can I write it like this? I'll take the 3 common. If I'll take the 3 common, it's going to be 1 minus x ka whole cube, right? I can do this. I can take the 3 common. This value is equal to 4 divided by 27, correct? Now this is going to be 4x square divided by 1 minus x multiplied by 1 minus x ka cube multiplied by 3 3s are 9 3s are 27 is equal to what? Is equal to 4 divided by 27. Can I say this 4 and this 4 will get cancelled out? This 27 got cancelled out. So what am I left with? I'm left with x squared divided by, this is 1 minus x ka cube, 1 minus x raised power 1. So it's going to be 1 minus x ka 4, right? Is equal to 1. Correct? Now how to solve this one? I think at the end we'll be having the quadratic equation, right? At the end we'll be getting the quadratic equation, guys. So this is, I can write it like this. I can write it as x divided by 1 minus x ka whole square is equal to 1, right? If I take the square root on both the sides, I'll be getting this x divided by 1 minus x ka whole square is equal to 1. So it's going to be simply x divided by 1 plus x square minus 2x is equal to 1, correct? So I told you I'm going to get the quadratic equation, which is x is equal to 1 plus x square minus 2x, correct? So it's going to be x square plus 1, this is minus 2x minus x, minus 3x is equal to 0. If I'll solve this equation, can I get the value of x from here? If I'll solve this equation, can I get the value of x from here? Definitely I'm going to get the value of x from here, okay? And you can do it from it, okay? You know how to factorize it, middle term splitting, or that formula x is equal to minus b plus minus under root b square minus 4ac by 2a, correct? Now, after getting the value of x, what was I supposed to calculate basically? Wasn't I supposed to calculate the concentration of NH3 at equilibrium? And if you remember, the concentration of NH3 at equilibrium, the concentration of NH3 at equilibrium was equal to 2x, right? Very simple. So if you get the value of x, multiply that x by 2, you are going to get the concentration of NH3 at equilibrium, which we guys were supposed to calculate, right? Right, guys, let me know in the chat box if the concept is clear to everyone. Let me know in the chat box fast. Let me know in the chat box fast if it is clear to everyone. Wonderful, guys, great. Okay. Let's move on to one more question. Let me see if you can solve this question or not. Let me see if you can solve this question or not. A very, very simple question it is. I'm telling you. It's a very simple question. It's a very simple question. Let me know the answer fast. Till then, I can have some water. All right, let me show you this question as well, guys. Have a look. We are given with a reaction. What the reaction is all about? We are given with a reaction like this: N2 gas plus 3 times H2 gas is in equilibrium with 2 times NH3 gas. This is something which is given to me, right? This is something which is given to me. The partial pressure of N2 and H2 are 0.8 and 0.4 atm at equilibrium. Fine, great. So at equilibrium, I'm given with the partial pressure of N2 as well as H2. For N2, it's given as 0.8 atm, right? The partial pressure of N2 at equilibrium is given as 0.8 atm, and the partial pressure of H2 at equilibrium is given as 0.4 atm. Correct? The total pressure of the system at equilibrium is 2.8. Very simple, guys. Total pressure at equilibrium is given as 2.8 atm. Calculate Kp for the reaction. Calculate Kp for the reaction. See, guys, it's a very simple question. First of all, at equilibrium, the total pressure of the container in which this reaction is taking place, at equilibrium, total pressure is equal to 2.8. So can I say the total pressure of the container at equilibrium is going to be equal to partial pressure of N2 plus partial pressure of H2 plus partial pressure of NH3, right? At equilibrium, I'll be having certain moles of N2 left, I'll be having certain moles of H2 left, and I'll be having certain moles of NH3 which would have got formed. So whatever is going to be the total pressure of the resulting mixture at equilibrium, that will be the sum of partial pressures of each. That will be the sum of partial pressures of each. Very, very simple. So total pressure is equal to 2.8, and total pressure, I can say total pressure is equal to partial pressure of N2 plus partial pressure of H2 plus partial pressure of NH3. This value is basically equal to 2.8. This value is basically equal to 2.8 atm, correct? Now what am I going to do afterwards? I'm given with partial pressure of N2, I'm given with partial pressure of H2. Can I calculate the partial pressure of NH3 from here? It is going to be equal to 2.8 minus 1.2, correct? 2.8 minus 2.8 minus sum of the partial pressure of these two, 0.8 plus 0.4, that means 1.2. So 2 minus 8 minus 1.2, it's going to come as 1.6 atm, correct? So 1.6 atm is the partial pressure of NH3 over here in this reaction, okay? I have to calculate the value of Kp, since I got the partial pressure of NH3 as well, which is 1.6 atm. Now what am I going to do? I'm going to write the expression for Kp. What the expression will be like? Expression will be like partial pressure of NH3 raised power 2 divided by partial pressure of N2 raised power 1 multiplied by partial pressure of H2 raised power 3. I have got all the values. Right? Partial pressure of NH3 is given to me as 1.6 iska square divided by partial pressure of N2 is given to me as 0.8 multiplied by partial pressure of H2 is given to me as 0.4 ka cube. Can we solve it and get the value of Kp which we were supposed to calculate? Can we solve it, guys? Can we solve it? Can we solve it and get the value of Kp? Yeah? Exactly, you can do it, right? The calculation part is left. You can do it now. Correct? You can do it now. The value will be coming out to be as 50. Okay, the value is coming out to be 50. Okay, if I'll ask you what are going to be the units of this Kp right here? What are going to be the units of this Kp right here? What do you think? What are going to be the units? What are going to be the units of Kp? Tell me fast. What are going to be the units? Do you remember Kp units used to be atm to the power delta Ng? Delta Ng for this reaction is -2. So it's going to be 50 atm raised power -2. Right? Isn't it? Exactly, Yashwant. atm to the power -2. Yes, Princey, absolutely, yeah. Wonderful, guys. Now, let's move on to one more question. Just try it out. Give it a try. One more question you have. One more question is there on your screen. Just give it a try. In an experiment starting from 1 mole of ethyl alcohol, 1 mole of acetic acid and 1 mole of water at 25 degrees centigrade, okay, the equilibrium mixture on analysis shows that the 20% of the acid is esterified. Calculate the Kc for the reaction. What do you guys think? Can we do it? It's a simple question, guys. See how am I going to approach to this question. See, guys, what is given in the question? At time t is equal to 0. I'm given with 1 mole of ethyl alcohol. I have got 1 mole of acetic acid as well at time t is equal to 0. And at the same time, I have got 1 mole of water as well at time t is equal to 0. Correct? This is something which is given to me. And at the same time, the equilibrium mixture on analysis shows that 20% of the acid is esterified. 25% of the acid is esterified. 20% of the acid is esterified. What does that mean? That means 20% of the acid has reacted. 20% of acid. How much that is? 20% of this acid. Wait, where is the acid? This is acetic acid, right? 20% of this acid has reacted. Initially, I have 1 mole. That means 20% of this 1 mole has reacted. What is the 20% of 1 mole? That is 0.2 moles. Correct? So I can say over here at equilibrium, out of 1 mole of CH3COH, out of 1 mole of acetic acid, 0.2 moles have reacted. If 0.2 moles have reacted, so how many moles will be left? I'll say 1 minus 0.2 moles of CH3COH will be left at equilibrium. Correct? Similarly, 1 mole reacts with 1 mole. So 0.2 moles should react with 0.2 moles. So how many moles of this ethyl alcohol will be left? I would say 1 minus 0.2 as well. Okay. How many moles of this ester have got formed? 1 mole gives 1 mole. So 0.2 moles should give me 0.2 moles. Right? And already in the mixture, how many moles of water I had? I had 1 mole of water in the beginning itself. Now some extra amount of water is getting formed. See, 1 mole is giving me 1 mole of water. So 0.2 moles are going to give me 0.2 moles of water as well, right? So it's going to be 1 plus 0.2. Very, very, very simple. Got it? Got it? Isn't it clear? Isn't it clear to everyone? Tell me fast, tell me fast. Tell me fast, guys, tell me fast. Tell me fast, tell me fast. I got the moles of reactants and products. I got the moles of reactants and products at equilibrium, right? Now, let's read the question again. In an experiment starting from 1 mole of ethyl alcohol, 1 mole of acetic acid and 1 mole of water at 25 degrees centigrade, the equilibrium mixture on analysis shows that 20% of the acid is esterified. Calculate the Kc for the reaction. Okay, fine. That's great. That's great. Have a look. How am I going to write the expression for Kc? How am I going to write the expression for Kc? The question is done, guys. Let me tell you, let's assume the volume of the container in which the reaction is taking place as V. That means let's assume the volume of the system as V. If I'll divide this term by V, if I'll divide this term by V, if I'll divide this term by V, this term by V, what am I going to get? I'm going to get the concentrations of each reactants and products from at equilibrium, right? Very simple. So Kc value is going to be equal. Kc value is going to be equal. I'm going to write concentration of this ester at equilibrium. How much is that? That is 0.2 divided by V. Raised power stoichiometry coefficient, that is 1. What about the concentration of this water at equilibrium? 1 plus 0.2, that is 1.2 divided by V to the power 1 divided by. What about this one? This is going to be 0.8 divided by V to the power what? To the power 1 multiplied by this again going to be 0.8 divided by V to the power 1. Can I say this V got cancelled? Can I get the value of Kc from here? Can I get the value of Kc from here? Isn't it simple, guys? Isn't it simple? Very, very simple. Okay, Yashwant is getting 3 by 8 answer, Priya is getting 3 by 8 answers, Princey is getting 3 by 8. So I'm going with you guys. So, okay, it must be 3 by 8 only then. Okay. What will be the units of Kc? Tell me fast. What are going to be the units of Kc? Tell me, what are going to be the units of Kc? What are going to be the units of Kc? Let me know fast. Let me know fast. What are going to be the units of Kc? Yashwant is saying no units. Kc units, if you remember, that's moles per liter to the power delta Ng. Delta Ng for this reaction is 0 because everyone is in liquid state, right? If delta Ng is 0, so it's going to be unitless at right now. Right? Wonderful, guys. Great. Okay, I'm moving on to one more question then. Let me move on to one more question. Let's see if we can solve this question or not. This is again a bit lengthy question, okay? This is a lengthy question. Okay, this is a lengthy question, but you'll get one more important concept right here in this question, okay? I believe this is the lengthy question, but at the same time, you are going to get one more concept right here from this question. See, guys, 0.15 moles of carbon monoxide taken in a 2.5 liter flask is maintained at 500 Kelvin with a catalyst so that the following reaction takes place. What is the reaction which is taking place? Carbon monoxide gas plus twice H2 is in equilibrium with CH3OH gas. Okay, let me write the reaction first then. This is carbon monoxide gas. It is reacting with twice H2 gas. It's reacting with twice H2 gas and it's in equilibrium with what? It's in equilibrium with CH3OH gas. CH3OH gas, right? This is the reaction which is given to us. This is the reaction which is given to us. Now, people, at time t is equal to 0, what am I given with? What am I given with? I'm given with 0.15 moles of carbon monoxide are taken in 2.5 liter flask. That means this reaction is taken, this is getting carried out in a flask whose volume is 2.5 liters. And initially, I have taken 0.15 moles of carbon monoxide. Okay? Okay, 0.15 moles of carbon monoxide taken in this flask is maintained at 500 Kelvin with a catalyst so that the following reaction takes place. Okay, hydrogen is introduced until the total pressure of the system is 8 atm. Okay, I'm going to introduce hydrogen gas. Till then, I'm going to introduce hydrogen gas until the pressure of the system becomes equal to 8.2 atm. Till then, continuously I'm going to add hydrogen gas. For example, I have added A moles of hydrogen gas. For example, after adding A moles of hydrogen gas, the pressure at equilibrium, the total pressure at equilibrium got equal to 8.2. Then only, okay? And what is given? And 0.08 moles of methanol is formed. Okay, at equilibrium we are given with 0.08 moles of methanol as well. Calculate Kc. See guys, see. Again, it's a very simple question. Again, have a look on the equation. See, I have got 0.15 moles of carbon monoxide, right? Now what am I doing is, I'm adding some H2 gas into this. I'm adding continuously and H2 gas unless the total pressure of the reaction, total pressure of the mixture at equilibrium becomes something 8 point something, right? Which is given to us, 8.2. Okay. Now, for example, I'm assuming I have added A moles of H2, then only the pressure of the mixture at equilibrium was equal to 8.2. Correct? Now, at time t is equal to 0, for example, I have got 0.15 moles of this, A moles of this, so I'll be having 0 moles of this. Understand properly what I'm going to do. Let's assume at equilibrium, out of 0.15 moles of carbon monoxide, let's assume X moles have reacted. If X moles have reacted, I will be left with 0.15 minus X moles of carbon monoxide at equilibrium, right? Now again, 1 mole of carbon monoxide reacts with 2 moles of hydrogen. So X moles would have reacted with 2X moles of hydrogen. How many moles of hydrogen I had? I had A moles. Out of A moles, how many are reacting? 2X are reacting. So I'll be left with A minus 2X moles of hydrogen at equilibrium, right? What about this CH3OH? 1 mole gives 1 mole. So X moles should give me X mole of it. X mole should give me X mole of it. Correct? Okay. Have a look, guys. Have a look. What is this X right here? Basically X are the moles of CH3OH at equilibrium. And this is given to me. 0.08 moles of methanol is formed at equilibrium, right? At equilibrium, 0.08 moles of methanol are formed. So I would say X value right here is given to me as 0.08. Correct? And at the same time, total pressure of the mixture at equilibrium, that's also given to me. How much? That is 8.2 atm. That's 8.2 atm, right? Now people, understand one more thing. See, at equilibrium, how many moles do I have? How many total moles do I have in the container at equilibrium? These many total moles of each reactant and product I have at equilibrium, correct? What is the temperature of the container at equilibrium? Temperature is given to me 500 Kelvin. What is the volume of the container? That is equal to 2.5. First of all, what am I going to use? If I'll use the ideal gas equation, PV is equal to nRT. Why am I using this? Understand one thing. For example, I'm using this ideal gas equation at equilibrium. And at equilibrium, I have got few moles of carbon monoxide, I've got few moles of H2, I've got few moles of CH3OH as well. Correct? So this P is going to be the pressure of the mixture at equilibrium. And is the pressure of mixture at equilibrium given to me? Definitely. Pressure of mixture at equilibrium is given to me as 8.21 multiplied by, what is the volume of the mixture at equilibrium? Volume of the mixture is going to be same as that of volume of container. How much is that? Volume of container is 2.5 is equal. What is this N? N is the total moles present in the mixture at equilibrium, correct? Total moles present in the mixture at equilibrium, right? And what is the temperature? What is the R value? R value is simply 0.0821 multiplied by temperature is given to me. How much is it? Temperature is 500 Kelvin. So can I calculate total moles present at equilibrium in the container? Can we do that? We can do that definitely, right? So how many total moles I'll be getting from here? I'll be getting, this is 8.21 multiplied by 2.5 divided by 0.0821 multiplied by 500, correct? So this is going to be 1. This is going to be 100. So it's going to be 250 divided by 500. 250 divided by 500 is how much? 0.5. So total moles present in the mixture at equilibrium is equal to 0.5. Can I say total moles present at equilibrium in the mixture is going to be 0.15 minus x plus a minus 2x plus x, right? And this value is equal to 0.5. Can I say that? Can I say that? What do you think? What do you guys think? Isn't it right? Isn't it right? Let me know in the chat box fast. What do you guys think? Isn't it correct? Isn't it correct? I got the total moles of gaseous mixture. I got the total moles of gaseous mixture present at equilibrium, right? As 0.5. So I can say total moles present in the mixture at equilibrium is going to be moles of carbon monoxide left at equilibrium plus moles of H2 left at equilibrium plus moles of CH3OH formed at equilibrium. I can say that. Now people understand one thing. Understand one thing. If I'll consider this equation, what this equation will be like now? See, this x and this x got cancelled. Very simple, correct? So this is going to be 0.15 plus a minus 2x. X value is 0.08. So 2x value will be 0.16. So it is minus 0.16. It is equal to 0.5. It is equal to 0.5, correct? It is equal to 0.5. It is equal to 0.5. So can we get the value of a from this equation? Can we get the value of a from this equation? Definitely I'll be getting the value of a. Let me write it over here. The value of a over here is going to be equal to 0.5 plus 0.16 minus 0.15. Correct? Let me know the value fast. Let me know the value fast. Let me know the value fast. A value is going to be equal to 0.5 plus 0.16 minus 0.15. Tell me fast guys, what will be the value coming? What is the value coming? Is it coming as 0.6? Is it coming as 0.6? Or 0.51? Definitely, it will be coming as 0.51. So A value I got as 0.51. A value I got as 0.51. Correct? A value I got as 0.51. Correct? Now people, if I got the value of A, now understand what am I going to do? Understand what am I going to do? A value I got as 0.51. So I'm going to write it somewhere here. A value I got as 0.51. I'm going to erase every calculation which I did over here. Okay? See guys, if A value I got, this is basically the number of moles of carbon monoxide at equilibrium. So it's going to be 0.15 minus x. X value is 0.08. Correct? The value will be how much? 0.07. A minus 2x. A value is how much? A value is 0.51. 0.51 minus 2 into 0.08. That is 0.16. What is the value coming? Value will be 0.35 around. Yeah? 0.35. And this x value, we already know this is 0.08. I got the moles of each reactant and product at equilibrium. Correct? If I divide these moles by the total volume, which is 2.5, am I getting the concentration of each reactant and product at equilibrium? Yeah? If I got the concentration of each reactant and product at equilibrium, can I simply write the expression for Kc? Kc expression for this reaction is going to be simply concentration of CH3OH to the power stoichiometric coefficient, that is 1, divided by concentration of carbon monoxide gas to the power 1 multiplied by concentration of H2 gas to the power what? To the power 2. I have got all the values. What is this basically? This is the concentration of CH3OH at equilibrium. This is the concentration of carbon monoxide at equilibrium. This is the concentration of H2 gas at equilibrium. Correct? Very, very simple. Very, very simple. I have all the values. I can just put the values into this equation. I'll get the value of Kc from here. Ronit, it's simple. I got the moles. Moles of carbon monoxide at equilibrium I got as 0.07. Moles of H2 at equilibrium I got as 0.35. Moles of CH3OH at equilibrium I got as 0.08. I'm dividing these moles at equilibrium by the total volumes. I'm going to get the concentration of each reactant and product. After getting the concentration of each reactant and product, I can use these values into this equation. I'll be getting the value of Kc over here. Which I was supposed to calculate, correct? Wonderful, guys. You can do the calculation part and let me know in the chat box afterwards, okay? All right, one more question for you, but this is going to be your homework, okay? This is going to be your homework. I'm going to give you a hint for this question. If total pressure at equilibrium for the mixture is 2 atm, then calculate Vf. Vf means volume fraction. Then calculate volume fraction of Cl2 at equilibrium. Kp value is given and the reaction is given. Let me tell you guys, whenever you'll be having a gaseous mixture, if the gaseous mixture is present at constant pressure and temperature, if the gaseous mixture will be present at constant fixed pressure and temperature, its volume fraction is taken as its mole fraction. Okay, volume fraction of any gas in the mixture will be always equal to the mole fraction of the gas. Let me give you hint for this. If whenever I'll be having a gaseous mixture which is present at the fixed pressure and temperature, constant pressure and temperature, the volume fraction of any gas present in the mixture is going to be equal to the mole fraction of the same gas present in the same mixture, right? This is your hint for the question. Do let me know the answer in the comment box. I'll be waiting for your answers, okay? Do let me know the answer in the comment box afterwards. Correct? All right, guys. So the time is up. Let me directly go to the last slide. Rest everything you know. Okay, so this was all for today, guys. I'll again meet you guys tomorrow at 3 p.m. in which in the tomorrow session, let me tell you, we are going to talk about one more important topic from thermodynamics, and the last topic of thermodynamics, that's what we call as Gibbs free energy. Tomorrow we are going to complete the thermodynamics chapter, right? And do go through the session again. Wherever you find any sort of difficulty, any sort of problem, any sort of doubt, do let me know on my Telegram or the Instagram. Wherever you find me, do let me know about that. And please do like, share and subscribe the channel at the same time so that everyone will get benefit out of it. Okay, so I'll meet you guys tomorrow at the same time. Till then, bye bye, take care, God bless you all and love you all. Bye guys, take care.